Welcome to today's webinar, Catching Up and Moving Forward, a discussion of findings from Zearn's new study on learning acceleration hosted by the Educating All Learners Alliance, or ELA for short, and Zearn. My name is Aurora Jegger from ELA, and I'll be your host. Before we dive into today's content, I'll share some information about ELA. We are a coalition of organizations dedicated to producing and sharing resources, programs, and events just like this dedicated to supporting students with learning differences. With us today are Grace Carroll, Brianna Henderson, and Emily Murphy from Zearn. I will pass it over to Grace from Zearn to start today's presentation.
Hi, everyone. Thanks so much for joining us today. As Aurora said, I'm Grace. I'm on the team at Zearn supporting teachers, educators, and schools. I'm so thrilled that you took some time to join us to hear about this really exciting new research on accelerating math learning for every student. We're honored to be an ELA partner and to support the amazing work that ELA does on behalf of all learners. So after 2 years of varied disruptions to students' math learning, teachers are entering this school year knowing that each of their students will need ongoing and wide-ranging support. Teachers need practical strategies to address unfinished learning while ensuring students don't fall further behind. The research we're sharing today shows that learning acceleration can help all students catch up and move forward in math, and provides promising evidence that it works at scale. So I'm excited to dig into the findings together. Today, we're just going to spend some time digging into the findings in this new research paper on learning acceleration. We're then going to turn to the math itself to see what learning acceleration really looks like in practice. And I'll close by taking some time to talk about how Zearn supports learning acceleration programmatically across schools and districts. Our team is monitoring the chat, so please feel free to ask questions there at any time. I'll also try and keep an eye out to answer any live. Before we dive in, just a little bit of background on Zearn. Zearn is a nonprofit. Everything we do is driven by the belief that all kids are math kids. We support teachers with research-backed materials and digital lessons that give students the opportunity to deeply explore grade-level math concepts with built-in differentiated support. Zearn is currently used by 1 in 4 elementary students and more than 1 million middle school students nationwide. We've amassed one of the largest data sets on math learning in the nation that's based on more than 11.5 billion math problems that students have completed on our platform. As a nonprofit, we really consider it an obligation to ask questions and share insights from this growing data set to help identify breakthroughs in math teaching and learning. And since the start of the pandemic, we've been looking at student struggle in math to answer a question that's really top of mind to educators around the nation, which is what strategies will help all students catch up and move forward in math? So to answer this question, Zearn researchers analyzed more than 5 million teacher instructional decisions made for more than 600,000 students during the 2020, 2021, and 2021, 2022 academic years. These students represented all 50 states in 1st through 7th grades. Since Zearn for 8th grade is being released now, at the time of the study, we didn't have 8th grade in our historical data set. So another important thing to know about Zearn is that we're really committed to student data privacy. It's a key part of our research work. We use aggregated and anonymized data to contribute to collective learning on how to support all kids to love learning math. And specifically, we do not amass a profile of a student on Zearn. So for this research study, Zearn researchers were able to look at the same student multiple times over the course of the 2 years. We used a fixed effect model. And what that means is that we looked at the impact of each intervention strategy, remediation, and acceleration on the same student. So let me explain the progression that we analyzed. We'll imagine a student, we'll call her Brianna, and she's repeatedly struggling in math. Throughout the year, sometimes Brianna received a remediation intervention. That's where she practiced skills she didn't master during previous grades. And sometimes she received a learning acceleration intervention. That's where she received just-in-time foundational support connected to the grade level content she's learning. So we looked at each instance where she first repeatedly struggled and then received one of these two types of intervention. After that intervention, she returned to her grade level learning, and we then looked at whether or not she struggled on that next grade level lesson. So this means that we weren't comparing students who were remediated to a different group of students who were accelerated. We're actually comparing each student to themselves to see which strategy worked best for them to reduce their struggle and help them move forward in math. And we looked at this progression you're seeing here more than 5 million times for 600,000 students across the country. So researchers then honed in on student demographics to see if there were any trends. To do this, they used school level demographic information to measure how often a specific group of students, such as low income versus high income students, experienced remediation versus learning acceleration. So Zearn does not collect student specific demographic data. Because of the scale of the data set, we can draw conclusions about the classrooms and schools that have majority of students that are Black or Latino, for example. Other top researchers and research institutions use our data in this way to draw similar conclusions. So from this, we learned some really remarkable things. First, Zearn researchers found that when students experience learning acceleration, they struggle significantly less, 17% less, than when they receive remediation. Further, when a student consistently experienced learning acceleration, they completed twice as many grade level lessons, allowing them to struggle less, catch up, and move forward. So just to orient to this chart here, the vertical axis shows the percent likelihood that a student repeatedly struggled when they returned to the next grade level lesson. The horizontal axis represents the type of intervention decision that the student experienced, remediation or acceleration. Again, we looked at each individual student's experiences across a group of more than 600,000 students across first through seventh grades. And when we're comparing these bars, it's important to remember the same kids are on both the gray and blue bars. When a student experienced learning acceleration, there was a 17% decrease in the probability of continued repeated struggle than when that student experienced remediation. So by comparing students against themselves, this new data shows that teachers' daily intervention decisions can help students catch up and move forward. And this result we found really striking and somewhat counterintuitive. The intent of remediation is to avoid struggle. But we see from the data that a student is actually likely to struggle more. When students receive instead just-in-time support from connected prior concepts, they can move forward in their grade level content with less struggle. So unfortunately, we also saw that students in low income and majority Black and Latino schools were more likely to experience remediation than their white and wealthier counterparts. This is even when they already demonstrated the same level of success with grade level work. So let's look at this figure. This figure represents the percent of students by subgroup and the likelihood that you would be remediated even after they demonstrated success with grade level work. We see only 9% of students in majority white schools were remediated. In contrast, 15% of students at the same level in majority Black and Latino schools were remediated. And we see a similar trend based on income. 15% of students enrolled in low income students were remediated compared to 8% of students in wealthier schools. So in the face of this really unfortunate disparity, we then asked, how effective is learning acceleration by a subgroup? And we really found reason for optimism. The data show that learning acceleration, it works for all students. Our analysis finds that learning acceleration relative to remediation has a consistent positive impact for students at majority low-income schools and students at majority Black or Latino schools. So the horizontal axis here is divided into three groups of students. On the far left, we have all students in our analysis, then students at majority low-income schools and students at majority Black or Latino schools. Again, remember each bar is the exact same set of students exposed to each approach. The vertical axis shows the likelihood of repeated struggle on the student's next grade level lesson. So for all students, we again see that the students who experience remediation are 17% more likely to struggle on the subsequent grade level lesson relative to when they experience acceleration. And the next two categories break that down by subgroup. And really importantly, we see similar impacts of acceleration versus remediation. When students at majority low income schools experience acceleration, we see a 19% reduction in struggle. Similarly, when a struggling student in a majority Black or Latino school was assigned learning acceleration, they also struggled 19% less than when they were remediated. So again, at Zearn, we have demographic data at a school level, and we don't collect student-specific data. Right now, we don't have data on multilingual learners or students with disabilities or with learning differences at a school level, although they're both data sets that we'd love to work with states and districts on to append these findings and analyze the data more deeply for those subgroups as well. So now that we've grounded in the research, I want to turn to what does learning acceleration actually look like in practice? So Zearn has multiple layers of built-in learning acceleration in each of our digital lessons. While traditional curricula teach grade level math content with the assumption that students have mastered every concept from prior grades, Zearn takes a different approach. Our digital lessons scaffold grade level learning with real life context and visualizations that intuitively make sense to kids and draw connections to prior concepts that serve as an on-ramp to new learning. And when a student struggles, Zearn brings in the connected foundational content right into grade level learning to help students catch up on unfinished learning in the context of grade level math. So let's see this in context. Let's look at a problem from 5th grade, 2 divided by 1/2. The question assumes that students can use what they learned about division and fractions in prior grades. So let's return to our example student, Brianna. She doesn't quite have a full understanding of this concept yet. She comes across this problem in her grade level lesson and she's stumped. In a traditional remediation approach, Brianna would have been asked to complete a lengthy review of content from prior grades. She might have been given worksheets to practice adding and subtracting fractions. While that's a significant component of 4th grade math, that addition and subtraction of fractions won't help Brianna understand this division of fraction problem. She'd spend weeks, if not months, catching up, all while falling behind on this 5th grade content. So with the learning acceleration supports embedded in Zearn, Brianna can catch up right here and keep moving forward in her grade level math unit. So let's actually take a look. To start off this lesson, we asked students to just divide 2 by 2. Miss Joseph, our on-screen teacher, has 2 pounds of tomatoes and put 2 pounds in each bowl. These friendly questions from 3rd grade activate what kids already know, and along with the concrete representation of the bowls of tomatoes, gives them an entry point into this new concept.
Another one. I still have 2 pounds of tomatoes. If I put 1 pound in each of these bowls, how many bowls will I use?
So one of Zearn's central learning principles is that math is just a few big ideas, and there's always a way in. When we ground math learning in these big ideas, whole numbers and operations, fractions and decimals, ratios and proportional relationships, we build really dense connections that allow us to tackle any problem. Friendly on-ramps like concrete problem context and visual representations help students build and strengthen those connections. They help students see structure, make sense, and have something besides a list of steps to fall back on when they get stuck or encounter a new tricky concept. And that's what we're starting to see here. So through the context of bowls of tomatoes, this mini lesson is helping Brianna understand the known parts of the problem, the total amount of tomatoes, and the size of each group of tomatoes. She can relate the unknown factor, the number of bowls, to the number of groups. So Miss Joseph will use 2 bowls. So let's skip ahead a little bit and see where the lesson goes next.
Let's solve one more. It's a little bit trickier. I still have 2 pounds of tomatoes. If I put 1/2 pound in each of these bowls, how many bowls will I use? What division expression can we use to solve?
So we started with a problem-solving context. We made it accessible through video and discussion, and eased in with problems that students understand. And now we put in front of Brianna 2 divided by 1/2. The problem hasn't changed, the context hasn't changed, the thinking hasn't changed. Brianna can solve the 5th grade problem the same way she solved the 3rd grade problem. This new learning is a logical extension of the work she's been doing all along. So we have a 1/2 pound bowl, and Brianna will do the same thing she did with the 2 pound bowl and the 1 pound bowl. She's gonna pick 2 divided by 1/2. So let's move ahead just a little bit more.
This time, we'll use paper to help us solve. This rectangular paper represents our 2 pounds of tomatoes. First, let's cut the whole into 2 equal units. How many pounds of tomatoes does each piece represent?
So moving students from the actual bowl of tomatoes to now a piece of paper and next to the tape diagram is really significant here. It's an intentional move to help students see value in the tape diagram as a powerful tool to draw upon as they encounter more challenging problems with division of fractions. So primed by the lesson's opening questions, I know that 2 pounds divided by 2 is 1 pound.
Each piece of paper represents 1 pound. I'll put 1/2 pound in each bowl, so I'll cut each whole into halves. How many halves are in 1 whole?
Now we've come to our answer. So looking through the representation, I can see that there are 2 halves in 1 whole. And now I can actually count to solve the problem using the representation. There are 4 halves and 2 wholes. So 2 divided by 1/2 is 4. So this is learning acceleration in action. Students with unfinished learning are learning fractions and division at the same time that they explore this new concept of dividing whole numbers with unit fractions that they just learned with their teacher. So as a nonprofit, Zearn's one goal is to drive student achievement in math. It's why we built Zearn with learning acceleration in mind from the beginning. We're regularly assessing Zearn's impact on students' academic outcomes to learn how to best support educators using Zearn. As our most recent findings show, no matter the student's background, learning acceleration was key in helping students move forward with their math learning when compared to remediation. So knowing that, I want to share some additional results from a study where we looked at the lowest levels of math proficiency. So this is an analysis from 2 districts where 30% and 50% of students qualify for free or reduced lunch. Our analysis was based on measuring the impact of consistent Zearn usage on students who scored at the bottom 2 levels on state assessments in 2019. We then considered what was expected from each of these student subgroups in terms of growth over 2 academic years and translated that growth into years of learning. So this expected 2-year growth is represented by the blue line. Excuse me, the purple dots represent regular Zearn users, students who completed 3 or more lessons each week. And the orange dots represent students who did not use Zearn. So in both districts, District A and District B, students who used Zearn met or exceeded the 2-year growth benchmark, growing more than 2 grade levels in 2 years, despite the learning disruptions of the pandemic. In District B, students who scored at the lowest level in 2019 grew 3.1 grade levels in 2 years when using Zearn alongside their curriculum. In other words, over 2 years of pandemic learning, the most struggling students experienced more than an additional year of learning beyond the expected 2-year growth. So for many students, this growth meant actually moving out of the lowest level of math proficiency. So in this study, almost 40% of the students at the lowest level of math proficiency who used Zearn moved up a full level or more on state assessments. So this figure shows the total students in District A who scored at the lowest level, level 1, on state assessments in 2019. So the green dots on the right represent the students at the lowest level of proficiency who consistently use Zearn in the 2020 to 21 school year. The gray dots on the left represent the students at the same starting level who did not use Zearn. So 39% of students at the lowest level of proficiency in 2019 moved up at least one full level in 2021. This is compared to only 4% of students at the same starting level who did not use Zearn. And this also held true in District B. In District B, 35% of students, of the lowest scoring students, moved up a full level or more with Zearn, compared to just 22% of non-Zearn users. And we saw this across all levels of student proficiency in both Districts A and B. Students who continually use Zearn were more likely to move up at least one full level on state assessments than students who used a high quality curriculum alone. So while many factors influence student achievement, this analysis provides promising evidence that Zearn's embedded learning acceleration supports all students to catch up on unfinished learning and access grade level math, even and especially those students who are furthest behind. So just to close, I just want to emphasize that central to our mission at Zearn is the belief that with the proper supports, accommodations, and modifications, all children can meaningfully engage in mathematics. Learning acceleration is one of those supports, and our commitment to accessibility has deeply shaped our approach to math learning, as well as the way that students experience Zearn digital lessons. So we designed Zearn from the start to be accessible for all students, using the universal design for learning principles to maximize access and engagement for all students. We also have embedded supports and structures in each digital lesson, such as closed captioning and audio supports and more to help teachers accommodate the needs of diverse learners. And finally, we want to ensure that each individual student has the support they need to engage with Zearn and love learning math. We're dedicated to providing decision-making support to educators working in partnership with families on how to best provide access to Zearn math for students with learning differences and unique learning needs. We're adding a link to the chat now where you can find more information on Zearn's commitment to accessibility guide, as well as our in-depth guide to assistive technology and instructional accommodations with Zearn. So thank you so much for joining me today. We're adding a link to the chat now where you can access our new research paper on learning acceleration to dig into these findings even more. If you have any questions about what we covered today or would like to learn more about how Zearn can support accelerating math learning, please don't hesitate to reach out to info@zearn.org. Thank you so much.
This is Aurora. Thank you. And on behalf of ELA and Zearn, thank you for joining us today for Catching Up and Moving Forward, a discussion of findings from Zearn's new study on learning acceleration. You can check out our website at educatingalllearners.org and follow us on Twitter at educateall_org. Also be sure to check out Zearn at their website, about.zearn.org, and follow them at ZearnED. Thanks, everybody.